Hey everybody, welcome to another Intro to Java Programming video. In this video, I'm going to demonstrate making sure that we can get an oval drawn into the frame all the time, no matter what. This is something that people seem to have a little bit of trouble with, so let's dig in. Right now, I don't have anything special. I've just got a frame that when I run it, it's going to be 600 by 600. You can see it there. Inside here, I've got the very basic stuff that I would normally have in a standard template. I've got a class called OvalPractice that extends JFrame. I've got two constants, frame width and frame height. I'm instantiating an object of my class, OvalProject. I'm calling it frame. I'm setting the size on that, setting it by frame width and frame height, setting up the default close operation, exit on close, and setting visible true. And I've got my paint method down here. First thing I'm going to do here is super.paint. As always, don't forget this. People still forget this. That makes sure that the painting is going to be done properly. All right, let's dig right in. I'm going to draw an oval, and I'm going to draw it right up in the upper left-hand corner. Fill oval. I'm going to set it at 0 and 0, and I'm going to make it 100 by 100. When I run this, you'll see that it's going to appear up in the corner, but it's cut off. This is a problem. As we've seen before, the graphics context in JFrame is overlapped by the edges of the frame by a little bit. What we want to do is try and figure out what those offsets are, what those overlaps are. All right, so I'm going to push the oval down until it's fully in the frame. So I'm just going to go to the Y set here, and I'm going to start at 20 and see if that works. Run it. It's still overlapped by a little bit. So I'm going to push it down even further. Go down to 30. And it's just about fully in the frame. You can see that there's a little bit, I think maybe it is fully in the frame, but that little bit right there might be chopped off. There might be a little step above that that's chopped off. So I'm going to go to 31 just to be safe, to make sure it's fully within the frame. Now let's check it. That looks like it's fully on the frame. So it looks like our top offset is going to be 31. So anytime you draw something, you want to add a 31 pixel offset so that we make sure that it doesn't go off the top side. Now we've got to deal with the left side, and that's going to be our x-axis. So if we want that to shift over to the right, that means we've got to add to it. If it's at 0 right now and it's overlapped on the left side, that means we have to add a higher number to the x. So I'm just going to start with 10. Well, I'll just start like I did before. I'll start at 20 and see where we are. And you can see that it's fully in the frame, but it's quite a bit over. Okay? So let's try 10. And you can see that it's fully in the frame, but there's still a little gap there. Let's try 9. And that looks pretty close. I'm going to try 8 and see if it overlaps at all. I can see that there's one little pixel there that's the edge of that oval. That's right on the edge. But let's see if it goes off the frame at 8. And that little pixel right there is still on the frame at 8. I think 8 or 9 is safe for our offsets. We're at 9 or 8 and 31. Let's see what 32 looks like and see if that's okay. 32 looks pretty good. I'm going to go all the way up to 35 and see what that looks like. Okay, now it's fully in there by quite a bit. That's almost 5 pixels off. So I'm going to go to 32, check it again. See if there's any gap up at the top. And there's about a 1 pixel gap at the top, so 31. 31 looks like what it is. Let's just say 9 and 31 to be safe, and those are going to be our left offset and our top offset. Okay, so what I can do here is I can just make some variables just to make sure that I store them. Top offset was going to be 31. And then left offset was going to be 9. And I'm going to use those variables in place of these hard-coded values. Left offset and top offset. There we go. Now, our oval is 100 by 100. Now I'm going to try drawing another oval, and I want to get it to draw all the way on the right side at the top. Okay? So G dot fill oval, and if it's going to be at the top, we're going to use top offset. And if it's going to be all the way to the right, we need to push it over to the right. Now, we know that our frame is going to be 600 wide. So let's try that. Let's go 600, top offset, 100 by 100. So we've got an oval that's 100 by 100. Its X is pushing it over 600 pixels because that's how wide our frame is. And the top, it's going to put it right at the top using that offset as we have. So I'll run it. And it's fully off the frame. It's not even showing up. If I pull the frame over, you can see that it's actually over here. Okay? So what happens is, as you know, an oval's origin is the upper left-hand corner. So if the upper left-hand corner is where it's going to start drawing, and I set the X to 600, that means it's going to put the X value of my oval at 600, which is off the frame. So it's going to push that whole thing off the frame. All right, so I've got to think about this a little bit. If I want the oval to show up fully within the frame, but I want it all the way to the edge of the frame, I have to be 600 pixels over minus the width of my oval. So I could do this, 600 minus 100, because I'm subtracting the width of my oval from the width of the frame, and run it, and it should show up. Ah, yuck. So we've got a little bit of an offset and overlap on the right side as well. So the left side we've got an overlap, the top we've got an overlap, the right side we've got an overlap. That means we have to have it left a little bit more. So this 100 offset is not quite enough. Now we could either set it up where we can consider the edge of the frame is a little bit lower than 600, or we can make this a little bit greater. I'm going to have this 100 width offset a little bit greater. So what I'm going to do is I'm going to subtract another. Let's see. If the offset on the left side was 9, I'm going to try subtracting 9 from the right side as well and see how that works. So 600 minus 100 minus 9. That means the width of the canvas minus the 100 for the width of my oval minus 9 for that overlap on the side. Let's see how that works. Okay, so we're sitting right at the edge there. Now, we're right on the right side. Now this is messy. I mean, I could just have it be, what is that, 500 minus 9, 491, but I'm not going to do that. I'm going to make these into variables. So I'm going to go int right offset is going to be 9. Oval width is going to be 100. And then I already have a way of getting the width of the frame. Now, I have my frame width here. And I also have a method called getWidth that we've seen before. So I'm going to use getWidth. So here's what we'll do. I'm going to make a variable called x. Oval 1x. Actually, this is oval 2. This is not oval 1. This is oval 2. Oval 2x. And what I'm going to do is I'm going to do some calculations to get us there. We know we've got a right offset. We know we've got our oval width and we've got our overall frame width. So I'll do this. Get width. Get width is going to retrieve the width of the frame no matter how big it is. When you stretch it bigger, it's going to get that width. When you shrink it down smaller, it's going to get that width. Okay? So I want to get the width, and then to make sure the oval shows up on the screen, normally you would subtract the oval width. Okay? So if I subtract the oval width from the width of the frame, that will put the oval pretty much in the frame. But then we've got that idea that the graphics context overlaps the right side. So you've got to have that right offset in there as well. So I'm going to subtract right offset. And there we go. Oval x2 can go right here. So we've got oval x2 and then top offset 100 by 100, and that should put us perfectly in the frame. All right, that's nice. Now I'm going to see if we can get it all the way down to the bottom. I'm going to assume that there's a bottom offset as well. Okay, we're pretty sure that that's going to be there. So what I'm going to do is I'm going to make a new int oval to y, and we know that we're going to have it the y value be the height minus the height of the oval. Okay, well, we don't really have an oval height yet, so I'm going to make one. I'm going to put it right up here with oval width, and it's going to be 100. Okay? So we know if we do get height, subtract oval height, and then we draw our new oval here. And I'll go oval 2x, oval 2y, and make it oval width by oval height. I'm now using only variables to draw my oval. There's nothing hard-coded in there. This is the ideal right here. This is what we're shooting for in our code, to have our code have no magic numbers and only things like constants and variables. These things here, these 100 and 100, are magic numbers. We want to avoid them. All right, so I'm going to draw this and see if it works. We all know that it's probably not going to work because there's going to be some overlap at the bottom. And I was right. You can see that it overlaps the bottom. Probably, I'm going to guess that it's probably going to be 9 pixels, because that's what the left and the right offset was. So I'm going to make another variable here, bottom offset. I'm going to set it to 9, and then I'm going to subtract that from this bottom offset. All right, now let's run it. And my oval is perfectly within the frame. Okay, so now what we have done is we've figured out the overall bounds of our frame to make sure we know what the minimum value and the maximum values for our x's and y's can be when we draw an oval. All right, let's get into the idea of generating a random. Okay, generating a random, we've done that before, and it's going to look something like this. I'm going to go int, and I'll go rand x gets, and we know that it's got to be cast to an int. We know inside of there we are going to have math.random. We know that math.random is going to have a multiplier, and it's going to have a multiplier of a minimum and a maximum. So what I'm going to do right now is I'm going to make two variables, int min, and I'll call it min x. And we know that the min x was going to be our left offset, right? So min x is going to be left offset. And if you don't have to do this, if you don't want to use all this stuff up there, if you're just doing this fresh in a new project, and we know our left offset is 9, you can do that, okay? So min x is going to be 9. And then we need a max x. That's going to be the highest possible value, okay? The max x is going to be, as we saw, the width of the frame minus the width of the oval minus that right offset, which is going to be, in this case, I'm going to go get width minus oval width minus 9, because the overlap on the right side was 9. So there's our min and there's our max. Okay. Now I could just throw all these two things directly into my calculations here, but I think that gets a little bit messy. So I'm going to use these two variables as replacements in my algorithm here. So we know that it's going to be max x minus min x, right? You've seen that before, plus 1, and that's going to be our multiplier. All right, now we're not quite done because then we have to have our shift, which is going to be min x plus that whole chunk of code right over here. All right, so I'm going to generate a random in between the max x and the min x. Now I'm going to do the same thing for y, but y is going to be a little bit different. So I'll go int min y is going to be 31, because we want to make sure that we're taking care of that top offset. So the minimum y value has to be 31. The max y is basically going to be the same as this, except it's going to be get height minus oval height, whoops, minus 9. All right, so I can copy this whole thing here and just do some modifying. Because I'm working with the random y here, I'm going to use min y, max y, and min y. Well, these are capital Y's, not lowercase y's. There we go. So this is going to generate a random in between the minimum x value and the maximum x value. This is going to generate a random y in between the minimum y and the maximum y. Let's just test this really quickly. And I'm going to x plus min x, pardon me, rand x, y, rand y. I shouldn't get anything bigger than 600 or smaller than, you know, the R9s and 31. Run it. There we go. So it was 487, 356. Those seem to be within the range. Now I'm going to see if these draw appropriately. I'm going to make one more oval right down here, and I'm going to use rand x and rand y. Hey, that says Randy. Run it, and the oval should always show up in the frame. So there's my random one. There's my random one. There's my random one. It's always showing up in the frame every time at a new location. And it appears to be working. I'm going to try something else. I'm going to comment these three ovals out. And let's test it with a loop. I'm going to take these things here, int I 0, I less than 100, I plus plus, And what it's going to do is draw 100 times, and we'll see if any of them draw off the frame. Look at that. They're all within the bounds of the frame every time. I think it would be uncanny if I generated my X and Y wrong and one of them did not show up off the frame. So this tells me, and now it's not a perfect test by any means, but it's a pretty darn good test. This tells me that my way of generating my ints is correct. We're not going to go off the edges. So let's review that again. First thing that we did is we found the edges of where our frame graphics context is. We saw that the offsets were 31 on top and 9 on left, right, and bottom. In order to generate our randoms, we had to get the width, subtract the width of the oval, and then subtract the offset. And then our min was going to be our offsets. Okay? And then we just did our min-max algorithm to generate our randoms within that range. All right. I hope this helps you figure out how to draw random smileys in random locations. Thanks for watching.